all the assignments that you did with so one of the attempts nearly of each of the question. So I will share that on the WhatsApp group today. But also nearly want to use this as prep so that again we go through some of the questions and then work through all 5 assessments, and then I'll also pick up the questions in the chat that we can look at that as well. Okay, so let's start with this. So what I wanted to do, let's just quickly, I just want to print screen some of these questions so that you can see. Okay, so gonna take from each question just something that so the first few questions is on study unit 1 and 2, and then we will go into study unit 3, 4, and 5 today as well. And then I thought on Tuesday we going on, and then Thursday will be our last session that you guys can just on Friday take it slow, that you don't need to overthink or do anything on Friday, that you guys can take a break before you tackle the exam on Saturday. Okay, so let me quickly put this in and then we can start. Okay, so just a few questions on study unit 1 and 2. So study unit 1 and 2, and again there was like a shared on our WhatsApp group the questions that there's about 1 or 2 questions on study unit 1, 1 or 2 questions on study unit 2. So on each study unit there is nearly 2 questions. So again, 11 study units. The exam is 25 questions, so about 2 questions per study unit, and then study units like study unit 5, and so the discrete where you have binomial, Poisson, and the discrete, that's normally 3 questions. And if you look at the confidence intervals between the confidence intervals and hypothesis testing, there's always normally 3 questions as well, because we look at standard deviation known, standard deviation unknown, and the proportion. So normally between those, there are 3 each. Okay, so let's start nearly back at the beginning. Study unit 1, we look at variables. So this one is telling us there's a few things. So the following information was collected. So industry is the type of employment industry, salary, annual salary in rands, Then we have experience, number of years, job level, junior, senior, or management, and remote ratio is the proportion of time working remotely expressed as a percentage. Okay, so let's see. When I ask which one of the following statement about variables is incorrect. Experience is a numerical value. So number of years of experience will be 1, 2, 3, etc. So that is a numerical value. If they set experience and then short, long, medium, or anything like that, then it would have been nearly more categorical and probably more a ranking kind of variable. But when it is numbers, numerical. Job level, so let's look. Job level, junior, senior, or management. Job level is qualitative, that's correct. Ordinal, correct, because there's order in this. So you first junior, then senior, then you go in management. So definitely there is order in this one. Industry, so let's look at industry. Type of employment, so it is qualitative, but if you are in government, financial, services, hospitality, health, doesn't matter. There's no order. So it is a nominal variable. So qualitative because it says something about it, and then nominal because there is no order in it. Salary, so salary, annual salary in rands. So that told me it's going to be quantity. So quantitative and continuous because some that they don't tell us exactly the rand value, so it will be a continuous number. So different numbers for different people. Um, so that is definitely a continuous. Remote, where is remote ratio? The proportion of time working remotely. Remote ratio, so it's not, I've read it as a ratio, so don't get caught up that is the variable is remote ratio. Is a quantitative, true, because it is numbers. Discrete, okay, so proportion of time working remotely. Okay, so I don't know this, that discrete is wrong. Quantity is right, but discrete is wrong because I don't know again what the values is going to be. So it should be quantitative continuous and not discrete, because again it is like the salary, that you are not able to say if it is going to be 11.5%, 6.2%. One actually does not know to what level it is going. So E would have been for me exactly the same as salary. Okay, and just be careful that you don't read ratio as part of the variables, or think of it as a ratio variable, um, because then it might also give you different answers. Okay, so that was in your first assignment. Some of you guys would have gotten this type of question. So again, I will share all 5 assignments with you guys if you haven't received it yet. And what it looks like is, remember there was 3 or 4 different questions, so it is one of those questions that was asked in the assignments. And then you will see, and let me quickly share it with you on the screen. You will see for first assignment it was done like this, but for all the other assignments the question is not completed so that you can see the answer. Okay, so that you can see what was being done. So I will share this with the presentation and all the things. So today we basically are just going through assignment 1 and 2, and I'm taking a few of them. Then I will look if you have specific ones that we need to cover on Tuesday. So I will build the two that is on the chat today. I will build into Tuesday's presentation. So you can tell me if there's any of the assignments question that we need to cover on Tuesday. So we will do that, and then on Thursday we will just have our last check-in. Okay, so let's look at question 3. So suppose that the data scientist study involves remuneration trends of all data scientists in South Africa. Suppose further that a sample of 2,200, data scientists were selected for the study, and that the average salary was determined to be 75,000 per annum. Which one of the following statements is incorrect? I will do that. Um, so let's look at the first one. Population average is unknown. Okay, so that's the interesting one. The average salary, so we come back to the first option. The average salary of a 200 data scientist is a population parameter. Okay, so that is definitely incorrect, because they say it is from a sample. So this is a sample statistic. So that is the incorrect known. The population of a study consists of all data scientists in South Africa. Yes, it does. Okay, so then if you see all data scientists, we know that is the population. So then the population average is unknown, is correct, because they don't say what is the population. So we know we're looking at the population, but the population average is unknown is correct. The process of using the sample average to estimate the population average is referred to as statistical inference. That again is correct. So important. So this again comes to some of the theory. So we're going to infer from the sample average what the population average is going to be. So that is correct. And then a histogram of a variable salary is an example of descriptive stats. That is correct as well. Okay, so the one that is wrong is where it refers to population parameter because it is actually a sample statistic. Okay, so in this one, they is definitely a kind of theoretical question. They give you a bit of information, but the rest is nearly understanding in that first chapter what is a population parameter, what is a sample statistic, what is a descriptive stats, all those kind of things. Okay, then question 4 in this first assignment was looking at still that now we go to a smaller sample. So instead of the 200, we go a bit smaller and we get 25 data scientists and the industries that they are working in. Okay, so then they ask us, construct a frequency distribution, then which one of the following statements is incorrect? Okay, so let's first roughly do a frequency distribution. And I'm just starting with retail because it's the first one here. So 1, 2, okay. Does anybody else have problems with seeing the screen? Okay, so it might be some of a connection error. Okay, so in any case, let's just quickly, I'm going to stop sharing and then share again. So if that didn't work, maybe try and just rejoin. Okay, so the retail, then EFSI, whatever that will mean. 1, 2, 3, 4, 5, 6, 7. Okay, then let's see healthcare. I'm just going to say HC for healthcare. 1, 2, 3, 4. Then automotive. 1, 2. Okay, we'll pick up if anything is not there. Media and entertainment. 1, 2, 3. What else? Telecommunication. 1, 2, 3, 4, 5. And what is left? None there, none there. So digital marketing, one of them. And then let's just check. 10, 14, 16, 19, 20, 25. So I do get 25. So then the frequency of retail is 12%. So retail is 3 divided by 25 times 100. And so that is 12%. Okay, so let's just, so they also did it like, okay, so there's no order in here. I just wanted to check. So a bit different to mine. I just started with the first one. They did it alphabetically. Okay, so no problem. They're not gonna see how you do the table. So that is definitely not you need to worry about. They're not going to see the table. So as long as you get the same answers, then you don't now need to go alphabetically first to check this out. And if you go across like this, where I went down, also perfect. So just make sure that in the end you have the same numbers, but how you get to that table, not a problem at all. Um, the percentage frequency of the telecommunication industry is 16% telecommunication, so that is 5 divided by 25. Let me just do that again because I'm getting the wrong answer. So that for me is 20%. Hmm. What is now? Yeah, that will be the frequency, eh? Okay, so let's see how many are wrong in this one. Because yeah, you actually right. The frequency is the number. Frequency is a number, yeah. So you're actually right. So yeah, the frequency of retail industry, the frequency is the count. So that is supposed to be also wrong. You are right. So that should be free and not the relative frequency. So let's see if there's not a few of these that are the relative frequency of that. So this is also wrong because it should be 0.24 and not 0.24%. Huh, okay, I'm gonna let me just flag this one because yeah, because your relative frequency, you spot on. So your relative frequency would be of that one is 7 divided by 24. Okay, so that is even okay. And I think that is because that's also wrong. Okay, so that must be which one is incorrect? Because, yeah, that's wrong, that's wrong, that's wrong. The relative frequency, but again, it should not have a percentage component because your relative frequency is just healthcare. So that should be 0.16 and not 0.16%. Okay, so that in a sense could also be wrong. And then employment industry is definitely not a numerical. Okay, so yeah, this one is a bit, it should have been just 0.16. That number is wrong. So that number should have been 0.28. That should have been free. And the percentage frequency of telecommunications was 5 divided by 25 is 20%. So that's why, phew, again, this is one of those where it might have been right in how the question was structured, but when it was now taken to typed out again, that might have sneaked in, but it should just be 0.16. So 100% correct. Frequency is the number. The percentage frequency, that is fine, that's a percentage. Relative frequency is basically a decimal, so it is the 7 in this instance divided by 25. The healthcare industry one is 4 divided by 25. So it must give you a decimal and not a percentage. Okay, so, and then like we've seen, employment industry, it's a categorical data, it's not numerical. So that's why so everything in this one was actually wrong. And here, again, one can see that is how the frequency is. That is how the relative frequency is. So it is supposed to just be a decimal, and your percentage frequency is the one with a percentage. Then the other thing, just to add to this question, is because it's not like bands of numerical data. So your frequency table, you can't for this one have a cumulative frequency because it does not make sense to say there's a cumulative frequency for automotive and digital or whatever. It just doesn't make sense, where if it was numerical values and it was kilograms, one could have said up to 5 kilograms or up to 10 kilograms. So then from a cumulative frequency, it will make sense. But in this instance, no cumulative frequency, because again, we don't have any cumulative that we can get here, because it really does not make sense to do anything cumulative in this environment. Okay, so I think there's one more. So, oh, okay. So it basically flows from the previous one. Which one of following graphical tabular methods is not appropriate for summarizing categorical? And it is that first one. We actually just spoke about it. So cumulative frequency distribution is the one that does not make sense when you're doing categorical data. Um, frequency distribution, yes, we just add it. Relative frequency distribution, yes, not a problem. Percentage frequency distribution, yes, not a problem. And cross tabulation, also perfect because you can, and that is what we do in chi-square, is every time cross tabulation between two categorical data sets. So that is perfect. Okay, so let's go into a bit more of those. Let me just copy it into our, and I am, remember I will share, so I'm just gonna now copy this in without the answer, but I will share with you guys on the WhatsApp group all the assignments today. So you don't need to worry. So let's just put that one in, and let's get one more that I don't want to add in, and then the rest will be on the next study unit. So let's just do those two. Okay, so question 6. So on question 6, in this table is extracted. Okay, so we get it from the book, but here's age numbers. So age groups 0 to 9, 10 to 19, and then population sizes. And then they just ask what percentage of a population is less or equal to 39 years of age. Okay, so they ask us the population that is less or equal to 39. So less or equal to 39. Okay, so we basically need to find out that sum of the yellow divided by the sum of everything. And unfortunately, I don't see that they somewhere say what the total is. So we will need to first work out the total. So the sum of the first 4 is 11,791 plus 9,986 plus 10,506 plus 9,726. Okay, so on this one, I would not even go to Excel. I would do this on my calculator because unless you type very quick in Excel, otherwise I would have thought this is just simpler to calculate, and then from this point I will just continue. So I have 42,009 already, so I will just say plus 6342 plus 4485 plus 2919 plus 1407 plus 564. Okay, so that gives me 42009 divided by 57726. And if I put it in a percentage, I get 72.77%. So I did not use Excel in this instance. I just use a calculator. And I will, let me just quickly share with you the screen, but we can again share in any case afterwards. So how we got to that first component is basically just the sum of the ones in yellow. So 11791 plus 9986 plus 10506 plus 9726. That will give you the 42009. And then we just continue on to get the total. So 42009 plus 6342 plus 4485 plus 2919 plus 1407 plus 564 will give me the 57726. Then those two divided by one another will give you a 72.77. Okay, so but yeah, once again, I will share the assignment with you on the WhatsApp group so that you have access to that. Let me just, for anybody not on the WhatsApp group who might be joining, let me just add the link to the WhatsApp group that you also have that. So please join it and I will send everything to you. Okay, so one more on this, so that then we can move over to the next study unit. So question 8. So this one was an interesting one, because if you look at question 8, you need to, so there's, what is it, about 20 data points. You need to work out mean, mode, then you need to say the distribution is negatively skewed or not. The mean, median, and mode are measures of central tendency. Okay, cool. So that one is already correct, but we want the incorrect one. The median data scientist salary is that. Okay, so we will need to first look at this data. Let's quickly see if this data is sorted or not. So again, before we even go and plot it in Excel to work things out, 405, so we can see this data is already sorted. Okay, so it might then mean that we don't need to go, even if we need to work out the average. So let's see. So I will look for the mode first, because the mode is the number that happens the most. And let's see if we can, so no repeats, no repeats, no repeats, nothing, nothing. Okay, there's 909, 909, so that's a repeat. Nothing else, so the mode is 909,000. Okay, so got that. Then mean we need to work out, so I'm going to skip that first. Distribution, it's negatively skewed, so if I look at those three, it is probably skewed because they're not similar. But again, we need to work out. So the one that I would then first check is what's happening with the median. So I would check. So we've got 20. So I know median is for one in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number in between these two is the median. So 850 plus 881 divided by 2. So 850 plus 881 divided by 2 gives me 865.5. So we know the median is the incorrect one. Okay, so without putting this into Excel, and that's why I said sometimes the 1510 guys that are also on the call, it is that sometimes we think we need to have Excel, but in this one we actually did not. Then if you see, so that one is wrong. So the mean is then actually 800. So then we can take it that the mean is 800. And now you can see mean is smaller than the median, and the median is smaller than the mode. So then if you go to that page of left skewed, positive skewed, negatively right skewed, that whole page, you will see that the distribution then is also negatively skewed because the mean is smaller than the median, and the median is smaller than mode. And so again, a bit of theory in here, but that is also how we can. So again, we did not need to go to Excel. We did not. So whenever I see these things that you really need to do a lot of calculation, first check if there's not one of the other things that is wrong. Because again, now for the 1610 that are allowed to have Excel, you're going to open up. Now you need to put in all the 20 data set or data numbers. And again, that also does take some time. Okay, so let's go a bit into this second study unit, or sorry, second assignment. But again, I will share with you all the assignments, and then please, if there is any of the assignments that you want me to work through again, please just ask. So on first, sorry, on Tuesday already, we will continue with the rest of the assignments. So 3, 4, and 5, and then on Thursday we will do anything that you guys want me to look at. So we will basically cover the rest then. Okay, so anything else then that we need to cover on Thursday, so that Friday is just a great day to get your thoughts together for the exam on Saturday. Okay, so I just want to add one or two more. And again, Ooh, okay. So I will, okay, I wanted to say 17, so a normal 550 time slot, but I might then change some of it. So I will ask on our WhatsApp group um, what times suit you guys. So it might even be Monday or Wednesday then. So I will ask on our WhatsApp group. Yes. So there will be there is definitely a mock exam that will be posted this week as well. Okay, cool. So let's check. So this one was assignment 2, and this is a bit more theory, because normally when we look at the study or assignment 2, you normally need to work out, you get numbers and you need to work it out. So like in the question 2 and those kind of things where they tell you certain things and you need to work out. So here we go and say, consider the following set. So they give you a sales agent, make 3 sales calls. At the end of each call, a purchase is either made or not. So purchase made, purchase made, purchase made, and then purchase, purchase not. The 2 experimental outcomes for each call are purchase or no purchase. The following sample space describe the experiment. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So um, how do you call it? Groups of outcomes. So consider the following events. Event 1 is the event that the agent makes no purchase. Okay, so there is the probability of event 1. So let's check. No purchase. So there's a purchase, there's one, there's a purchase. So there's at least one purchase. So there's only one outcome or event that has no purchase. So no purchase is 1/8. 1 divided by 8 is 0.125. So is that the one that is incorrect? Ah, we look for the correct one. Okay. Um, so let's look at, so the next one, let's just check the first option. The total number of experimental outcomes is 2. Okay, so how many experimental outcomes would you have said is in this one? And so I would have said, like I did, there, there is 8. So that is also wrong, but we're looking for the correct one. Okay, so let's see what is event 2. Event 2 is the event that the agent makes one purchase. Okay, only one. Okay, so there's 3. So let's go to event 4, where it is free purchase. So there's only one that is free purchases. So that is also 0,125. Okay, so let's look at, we've now done that. So only one purchase, so that's free, that's 2, that's 2, that's 2, there's 1, there's 1, there's 1. So we basically have 3 out of 8, that is 1 purchase. So 3 divided by 8 is 0,375. That is correct. That is actually our correct one. And then let's see, event 3 makes 2 purchase. So again, there's 2 purchase, there's 2 purchase, there's 2. So also 3 out of 8, which is 0,375. So you can again see no purchase, 1, 2, and 3. If you add all of them together, you will get 100%. So that plus that will be 0,5, plus that will be 0,875, plus the last one will be 100% or 1. Okay, so the one that is correct is event 2 with the 1 purchase. Okay, so giving you nearly the outcomes and how it looks like, so that you can work with that. Okay, so let me just go into the next one, so that we can go to question 2. So now with this, they give us 2 events, A and B. They tell us it is independent. Okay, so the first thing when we see it is independent, remember then probability of A times the probability of B is the probability of A and B. And so again, that is important, because then most likely what will happen is we need to do something to get or A or B, or probability of A and B. So furthermore, it is known that probability of B is something, that is something. What is the probability of A given B? Okay, so let's just check. Probability of A given B is equal to probability of A and B divided by probability of B. So we actually did not even need to have a probability of A. So probability of A and B, 0,16. Probability of B, 0,8. And then if we divide that, 0.16 divided by 0.8 is equal to 0.2. And that is option A. Okay, so they nearly have given us, well, not nearly, they've given us all the information that we need um, so that we can work this out. Um, you can also go into working out the probability of A if you wanted to, but in this one, it is actually not needed. Um, so yeah, so I think it is great to work out probability of A if you want to, but again, remember you guys have not that much time in the exam, so remember you have 25 questions. So if you have shortcuts that you can work with, use it. If you don't need to work out everything, that's also sometimes a positive, that we don't need to go into the detail and need to go into much. Okay, so let's look at the next one. And again, we'll they say extracted. Okay, so in that they don't give us any information that we can work with. Um, so they don't tell me what the total is. So what is the probability that an officer is male or that compensation was part paid? Part paid. Okay, part paid. So the or. So if we say probability of male or part paid, because again, we don't now want to go out and work out all the totals. So we want probability of male plus probability of part paid minus the probability of the and. So that component. So I would then say probability of male. So that's 754 plus 62 plus 61. Sorry, it's 877. Let's just add all of these together to get a total, plus 157 plus 7 plus 6. Okay, weird number, 147, 1047. I hope that is correct. And then if you add those two together, you get 96. Okay, so if we now need to work out, so now you'd basically just work out the probability of male. So it's 877 divided by 1047. So 0,8376. Okay, so it's not that one. Plus the probability of part paid. So that's 69 divided by 1047. So it's not that one. Then minus 62 divided by 1047, which is 0,05922. So then it is 0,8376 plus 0.0659 minus 0.05922, and we end up with 0.8443. Okay, so again, I marked what I needed to get so that I now don't go and work out paid in full, nothing paid, female. It's not needed. So just those small things that give you that 1 or 2 minutes extra, so that you can nearly free up some time. Okay, discrete. So when we look at the discrete, I think again what is important is to nearly check if there is not the easy answers, because probability, expected value. So I don't want nearly to do the expected first. That might then be that is maybe the correct one. But again, to do expected, you need to do a lot of calculations. So I will first go and say, let's look at, because the other ones are something that I can read off a table. So the probability that x is equal to 0 is 0.26. So it's not 0, it is 0.26. Okay, so incorrect, that's fine. Probability that x is at least 5. So at least 5, it's 5 or more. So that is 0.02 plus 0.02. So it is 0.04. That is incorrect. The probability that x is at most, so no more than 5, so it can still include 5, so it's all of them. So if I look at that, it's basically 1 minus 0.02, which is 0.98. Okay, so then again, we did not need to go to the expected. Let's just, the probability distribution of x is discrete uniform probability. Okay, so uniform would have meant that everything is the same. So it is definitely not a uniform probability. So that is incorrect. Uniform would have meant that if we have 7 options, it would have been 1/7, 1/7, so that your graph would have also looked like this. Everything would have been 1/7 from 0 to 7. So it would have just looked like this. So that is what uniform means. It's the same probability for each one. And then to work out the expected, you needed to say 0 times that to get 0, 1 times that, and then add all of them together to get the answer. So if you do that for all of them, we will get 1.72. But again, Um, I would even in the exam, if your expected value is option A, look at the other ones because again, it's easier to do just a probability of something than now to work out what is the expected value. Um, okay, so let's look at, so this is a discrete, and then obviously there is one on or binomial or Poisson, and let's see if they tell us in it what it is, else we will also identify for you guys. So let's just see. A fictional company suspects 13 of its employees of embezzlement of funds. A lifestyle audit of the 13 suspected employees is conducted to check whether they live within or beyond their means. This is known from similar cases in the past that is 60% or zero point 0.6 of the suspected. What is the probability that 6 out of 13 employees? Okay, so what is very important in this one is I don't think, and again, this is very important for you guys, that if we look at 13, that is probably not on your list. So on the table, I don't think N13 is there. So then for both of 20, or sorry, 1610 and 1510, that is not something that they will ask you in the exam. So in the exam, if that is not on a table for you to work out, they will not ask it. So let me just put this in here for you. So goes up until 10 and then 20. Okay, so they will not, even though we can get to 0 0.6 in all of them, something like this, where it is n equal to 13, they not they will not ask you because you don't have access to something like that. In the assignments, it was fine because you were allowed to use online tools. So I'm quickly just going to check binomial distribution calculator. So again, in your exam, don't they won't ask this because also they're not in the answers that I'm going to share with you guys. There is going to be um, the formula that is used, but again, that is going to take you some time. So they will not do this in the exam where it is going to be a non-number. So it will probably be in the exam 10. So let's quickly, if it was 10, it would have been 0, 0.6, and then we would work out the numbers between it to get there. So let me just put this into that calculator that I can show you. So that was 13. I think that was 0, 0.6. just quickly see what. So 60%. Sorry, wrong way around. And so here is 0.13 for 6 over 13. If it was less than or equal, so I will copy this in just that you guys can practice it as well. But again, we're not going to ask something like this where you're not able to use the table in the exam. Okay, so let me just get one for Poisson distribution as well. Okay, so here we go. Poisson distribution. Then we have at least covered most of the stuff. But I will again share with you guys all the assignments. So random variable x is Poisson distributed with a mean of 1,5. So if the mean is 1,5, remember lambda is 1,5. Your variance is 1,5. And then if you get your standard deviation, it is the square root of the variance. So I will first just check all of these ones to see if there isn't something that is not correct. So we're looking for the incorrect one. So that is correct. That is correct. Okay, so first, those unfortunately is correct. So then we will need to go to Poisson table. Let's check Poisson table of 1,5. So we are going to work with this one, 1,5 and that. So let's just check what we need to get. So probability x is equal to 1. So let's check probability x equal to 1, 0,3347, 3347, correct. Okay, let's first do probability smaller or equal to 1, so that is probability of 0 and 1. The probability of 0 and 1, so that's 0.2231, 2231 plus 0.3347, so that is 0.5578, 5578. That is also correct. So the incorrect one is that, but let's just check. So that is probability x bigger or equal to 1. So that is bigger or equal to 1. So that means it's everything from there straight through. So what we could have done is to say, instead of adding all of those, I'm just going to say 1 minus 0.2231. So the answer should be 0.7769, 0.7769. Okay, so that is what it should be. So you can also test it, but again, want to save time. But if you added all of those together, you will also get 0.7769. But again, it's easier instead of adding all of them to say 1 minus that. Okay. Okay, so that was nearly a very quick scan through of the first few chapters. So what we will do on, well, I'll find out now for you guys which is the best time slot for you for next week. So that will suit that there's no clashes with other assignments or other exams and other check-ins. I will just check with you guys what will work. So, but it will be between Monday and Thursday that we will have the next or the last two sessions. Yeah. So then I will on the WhatsApp group, I will share with you guys the presentation update. I will share the link to the session today, and then I will also share all 5 assignments that you have, that if you want to work out for prep, and then also ask me on those if we need to look into any one of those, and I will also take the 2 questions that was posted in the chat into the next session. But also feel free to ask any of those assignments if there's any questions that we need to look at, and we will do that. Okay, have a great Sunday and weekend still, everyone, and then we will see for 2 more sessions next week. Have a great one, everyone. Cheers for now.
Cheers.
Bye.
Yes, Gene. Thank you. Bye.
It's a pleasure. Thanks, everyone. Cheers.